Hi everybody, welcome to today's video. Radon is something in this business that we should all be pretty much used to dealing with because it is a very common thing here in central Indiana. It still amazes me after 17 years plus in this business how much misinformation and misunderstanding there is about radon. Radon is what we're going to call a somewhat or a mildly radioactive gas, and it occurs naturally in our environment in low concentrations. There is always a little bit of radon floating around in the air here around us, especially in central Indiana. And it actually comes from what's called primordial uranium in the soil. So basically, uranium that has been around for millions and millions of years. That's the source for radon. As that uranium breaks down, it eventually produces radon gas. So if you remember your high school physics at all, we're basically talking a little bit about the decay chain of uranium in the ground underneath of us. So as uranium radioactively decays, it forms all kinds of other chemicals and other isotopes along the way. And it goes from thorium to palladium and back to uranium and back to thorium. But the ones we are concerned about here is the decay chain that takes place when uranium eventually breaks down into radium, named by Marie Curie way back in the 1800s. And then that radium eventually breaks down into radon, actually specifically radon 222, which is what we're worried about. And then that will eventually break down into polonium and then a whole bunch of other stuff, including bismuth and lead and things like that. But that decay chain is what we're concerned about because that is actually what makes radium, I'm going to stumble over this all day today, what makes radon actually carcinogenic and actually what makes it a health hazard. And the reason for that is because of the half-life of the radon that we're dealing with. It is a relatively unstable isotope and it breaks down relatively quickly, especially when you compare it to some of the other elements in the decay chain before it. But basically, the radon that we're worried about lives for just a little bit under 4 days, and then it decays to polonium, which actually has a half-life of about 3 minutes, and then to a lead isotope, which lasts for about 27 minutes. The problem here is that it's a little bit unstable. It's way more unstable than a lot of its precursor elements, and it's more stable than a lot of the follow-on elements that come along. And that is going to give it just enough time to be a problem. So what we're talking about here, to shorten this up, make it a little bit more understandable, is that the uranium-238 in the ground takes a long, long time to decay, but it will eventually, over the course of billions and trillions of years, get to radium-226, which is stable for about 1,600 years, which then eventually decays to radon-222, which is what we're worried about it. The reason we're worried about that 3.8-day half-life, that almost 4-day half-life, is that gives that radon just enough time to seep out of the soil and the rocks and the ground underneath of us and to get into our homes and therefore to get into our lungs. So if that radon only has about a 4-day half-life and it's kind of percolating its way up out of the ground, by the time we inhale it, there is a pretty good chance that that radioactive decay, where it goes to polonium next, is actually going to occur inside our lungs. Thanks for watching. We'll see you in the next video.